the research we are doing in my lab, we are trying to make the electronic device in your smartphone, in your computer, in future cars and drones smarter, more energy efficient, can process information faster. So in my lab, it's all about how do we improve this kind of electronic system. So some of the current projects we're working on include leveraging novel analog computing capability to build on-device AI and machine learning, as well as real-time resource allocation for heterogeneous system with CPU and GPU, where you will find in, for example, self-driving cars. And we also look at versatile attack that might be happening in the self-driving system that's powered by deep learning perception models.
I'm working on the efficient computing system. So the efficient has two meanings. The first one is the energy efficient. This means that how can we make the computer more power efficient? It can use less energy and power, but it can do more computations. And the second meaning is that how can we manage the resources within the computer system to make it compute more fast. And the next what I will work on is that to evaluate how can we apply the energy efficient and the resource efficient computing in the autonomous system.
So my current project focuses on hardware acceleration for machine learning applications with a new technology, which is called in-memory computing. The in-memory computation provides a solution to solve the data movement challenge by exploiting the analog characteristics of devices to implement in situ vector multiplication inherent in the memory. So it can dramatically reduce the data movement and significantly improve the energy efficiency of the hardware accelerators. We use neural network training algorithms to train a neural network to approximate the function of these circuits. So we can achieve design automation of the traditional analog and mixed signal circuits with high energy efficiency and low area overhead.
One of the main things that we're trying to answer these days in our projects right now is that are self-driving cars safe enough to be on the roads today? We're trying to make sure that all these self-driving cars have a much more robust algorithm. So we try to foresee what are some of the issues that may face in the future when it's on the real road. And since we don't have access to any self-driving cars like Teslas or anything, we use a simulator like the one you see here. It's called Carla. It's a physics simulator. It simulates different vehicles, pedestrians, traffic lights, different weather scenarios. We can change what the car sees just a little bit and see if that confuses the car enough to make it go and crash. So we're also trying to collaborate with the different schools at WashU. For example, the architecture school, because they're much more proficient at building things in the real world. So we would like to take their help into building an urban city and see how well it works in a sort of realistic scenario. The lighting condition will not be real no matter what you try in a simulator. So that's some of the issues that we can kind of fine-tune with the physical system and create a much more robust algorithm.